Today we're going to look at some tools we have to be able to expand or condense logarithms, especially when they contain powers, when they contain factors, or when they contain quotients. We're still definitely wrestling with the idea of a log and its relationship to an exponential, the fact that they're inverse operations and that we can rewrite one as the other. And definitely in class these last couple of days there's been some frustration over how exactly to do that. We've been a little bit slow on the uptake. So we've got to nail that part of it down. But we want to move on and also see that the ability to kind of manipulate these log expressions can make our lives a little bit easier. Part of that has to do with expanding or condensing log expressions when they contain factors, when they contain quotients, or when they contain powers. So these are some properties that we've got. If b, m, and n are positive numbers and b is not equal to 1, these things are true. The log base b of m times n, so any product, can be rewritten with each factor having its own log of that base b. So log base b of m plus log base b of n. Similarly, when I have a quotient m divided by n, log base b of m over n can be rewritten with the numerator and denominator each getting their own log of that base. Now I'm going to subtract them. I'm going to take the difference. Log base b of m minus log base b of n. And when I have a power, m to the k, log base b of m raised to the k, I can take that power and put it out front. So k times the log base b of m. So to recap, each factor gets its own log and its own base. If I have factors in the numerator, we'll add those logs together. Factors in the denominator get subtracted, and any exponent of factor gets moved out front as a constant. As an example, let's go ahead and expand out these logs. So given the log base 5 of m to the fourth times n squared. So I've got a couple things going on here. I've got some powers and I've got a factor. So I know that I can write this as log base 5 of m to the fourth. It's factors, they're being multiplied, so add log base 5 of m squared. And then keeping in mind that the factors can come out front. So 4 times the log base 5 of m plus the exponent 2 times the log base 5 of n. Similarly, here I've got, remember the cubed root can be written as a 1/3 exponent. So I've got an exponent here. I've got a power in the numerator of a fraction and also a denominator here. So let's break this down. Remember, when I'm writing radicals to a power, that power can be applied to both numerator and denominator. So log base 3 of m to the 2/3 minus n to the 1/3. So the quotient here tells me I subtract. I took the cube root index, put that in the denominator of my exponent fraction. So now I'm going to bring my exponents out front. 2/3 log base 3 of m minus 1/3 log base 3 of n. Similarly, we can condense logarithms when they're being added or subtracted. If I have a constant in front of the log, it can be applied as an exponent of the factor. We're looking to get only one log expression. So if the logs are being added, we're going to multiply the factors together. If the logs are subtracted, we're going to divide the factors. And recall that these have to be of the same base. So a couple of examples. So here I have log base 2 of m plus 2 times the log base 2 of n. So a couple of things are going on here. I know m and n are going to be multiplied, and I also know that I have an exponent 2 on my n. So log base 2 of m n squared. In this case, I have a 1/2 out in front of my log base 2 of m, so that's going to go up as an exponent there. Minus means I'm going to divide these two, so my m is going to be in the numerator, my n in the denominator, 3 times the log base 2 of n, so that means I'm going to raise that as an exponent. Here I have 1/2. So we could write this log base 2 of m to the 1/2 over n to the third, or maybe a simpler way to put it, log base 2 of the square root of m over n to the third. So we can use this concept to help us solve some equations. If I have logarithms on either side of an equal sign, and they have the same base, I can write an equation. So the log and the base on the one side is equal to the log and the base on the other side of the equal sign. Once I have that, I can remove out my log and my base and solve the equation that remains. So as an example, log base a of x equals 2 times the log base a of 3 plus the log base a of 5. So on the left-hand side, my log base a of x, there's nothing to condense or expand there. I'm good. But here I can see that I'm going to be multiplying my 3 times 5. So it's log base a of 3 times 5. And in addition, this is 2 times the log base a of 3. That's 3 squared. So the log base 2 of 9 times 5, that's the log base 2 of 45. So log base a of x I should go back and point out that those are all log base a's. So the log base a of x equals the log base a of 45. That means x equals 45. Let's look at another example, this time with a difference, so I know that this is going to be a quotient. I have a log base b of 8 minus the log base b of 2. That's 8 over 2. The right-hand side, log base b of x plus 3. So let's simplify it a little. Log base b of something equals log base b of something. So I can drop the log and the base. Now over here, 8 divided by 2, that's 4. So I have this for an equation. And so x equals 1. Last thing we want to look at is these laws of logarithms to write down a numerical value for a log if we have a chance to expand or contract. So given these examples, and a log base 10 of 2 equal to 0.301, and the log base 10 of 3 equal to 0.477. So our first move here is to simplify these. So as a for instance, log base 10 of 2/3. So this is a subtraction. Log base 10 of 2 minus the log base 10 of 3. So now we can plug in our values. Log base 10 of 2, 0.301. Log base 10 of 3, 0.477. So you go to your calculator. 0.301 minus 477. And that value is negative 0.176. So another one. Now I have 6, which can be rewritten as 2 times 3. So now I have factors, which means I can write this as an addition. Log base 10 of 2 plus the log base 10 of 3. Now I go to my values. 0.301 plus 0.477. To the calculator we go. I get 0.778. Okay, one more. The log base 10 of 9, now remember 9 is 3 squared. So I'm taking the log base 10 of 3 squared. I can take the exponent 2 and write it out in front of the log. The log base, 2 times the log base 10 of 3. So the log base 10 of 3, 0.477. So the calculator we go, times 2. And we get 0.954. So some examples of expanding and contracting log expressions, going in both directions, writing one log from a string and taking one log and expanding it out in either a sum or difference, and then also being able to calculate when we're given values for particular logs. Be sure to take some time and summarize your notes. 3 things that you learned today, 2 things that you want to know more about, and 1 big question you still have. And if you're the type of person that likes to make sketches or graphic organizers, write down some random thoughts, how does this connect to things you've done in other classes, you can take some time to do that here as well.